first principles is kind of a physics way of looking at the world. And what that really means is you kind of boil things down to the most fundamental truths and say, okay, what are we sure is true or as sure as possible is true? And then reason up from there. That takes a lot more mental energy.
马斯克是当今世界首富，身价大约2000亿美金。他本人分享的成功经验就是第一性原理，这使他在电动汽车、航空航天、清洁能源等领域都取得了一些颠覆性的创新，乃至于现在成为世界首富。马斯克这里提到的第一性原理是古希腊哲学家亚里士多德提出的一个哲学观点。每个系统中存在一个最基本的命题，它不能被违背或删除。这不是什么心灵鸡汤，而是客观的在物理学领域应用的一种思维方式，即回归事物的本质，从最基本的物理學角度去解决问題。为了方便大家理解，马斯克给大家举几个例子。
People did say that, and for batteries, they would say, oh, it's going to cost, historically it's cost $600 per kilowatt hour, and so it's not going to be much better than that in the future. And you say, no, okay, well, what are the batteries made of? So first principles would be to say, okay, what are the material constituents of the batteries? What is the spot market value of the material constituents? So you can say, okay, it's got cobalt, nickel, aluminum, carbon, and some polymers for separation, and a steel can. So break that down on a material basis and say, okay, what if we bought that on the London Metal Exchange, what would each of those things cost? Like, oh, geez, it's like $80 per kilowatt hour. So clearly, you just need to think of clever ways to take those materials and combine them into the shape of a battery cell, and you can have batteries that are much cheaper than anyone realizes.
马斯克在这段访谈中提到，制约电动车发展的一个重要原因是电池成本过高，达到$600千瓦时。如果用类比的方式来思考这个问题，就会变成别人过去造的电池组成本很高，那么我们现在制造的话，成本应该同样也好不到哪里去。然而，用第一性原理来考虑这个问题则截然不同。第一性原理强调的不是和别人类比，而是强调严格的物理层面推理。用第一性原理来看，电池的物理组成是铜、锌、铝、碳。如果去伦敦交易所买这些材料要多少钱？其实只要$80千瓦时，只要找到一种聪明的方法，把这些材料组合成电池，就能得到非常便宜的电池。马斯克的这个访谈是2013年，而这个便宜的电池现在已经成功了。这个电池就是4680量产电池，也就是特斯拉电动车正在用的电池。利用无吉尔技术，提高了能量密度，降低了制造成本。现在成本大约$150每千瓦时，续航也提升了16%。
But I think the fact that reusability is important. This is an example of where first principles analysis makes sense, because if you were to look at, say, by analogy and say, well, let's look at prior efforts to achieve reusability, such as the space shuttle,
right.
Or the Russian Buran program,
right.
And say, well, those attempts at reusability did not result in any improvement in the cost of spaceflight. In fact, they increased the cost of spaceflight. So the shuttle on a shuttle budget was about $4 billion a year, and there were typically 4 flights per year. So obviously the cost was roughly $1 billion a year.
Right.
And this was much more than an expendable rocket of equivalent payload capability. So then people would look at this and say, well, based on that, it would appear that reusability increases the cost; it does not decrease it. However, this is not true if you look at it from a first principle standpoint. Because if you look at, say, what is the cost of the propellant used if you use a low-cost propellant such as refined jet fuel, and in the case of our rocket, the propellant cost is approximately $300,000 per flight, but the rocket costs $60 million. So that's a pretty huge, difference. You've got the cost of propellant essentially 0.5% of the cost of the rocket. It's comparable to that of a large jet, essentially. And so obviously, if you can achieve reusability, you can start to approach the cost per flight. The cost per flight would asymptotically approach the cost of propellant. you're factoring in maintenance and other issues. And so if something similar to aircraft occurred with rockets, then you might have the cost of maintenance and so forth be roughly equivalent to the cost of fuel as it is with airlines, which would mean, say a $600,000 cost per flight over time, which would therefore be a 2 order of magnitude reduction.
So this is really a good example to show that think in terms of first principles, radically different from think using analogy, right? Using analogy, you would not find anything possible, but from the first principle.
Absolutely, and the same can be said of even building the rocket in a reusable building a rocket whether expendable or reusable, to say what should a rocket cost. One could look at what rockets have cost historically and say, well, that's what rockets will cost. Or you could say, what are the material constituents of the rocket? If you were to say, what is the weight of aluminum, titanium, Inconel, carbon fiber, and other elements, and if you had them sort of arranged in a pile in raw materials in the room and had a magic wand and could rearrange the elements into the shape that you want, then that would describe the minimum possible cost of any given physical object. And so then the trick is how you get them in the shape effectively. And if you do that, you can see that the actual cost of the raw materials in a rocket, again, expendable or reusable, is quite small. It's only a few % of the price. So then the trick is, how do you rearrange those raw materials into the shape you want efficiently?
Wow, the lesson is, again, go back to the first principle.
Right.
Everything goes back to the fundamental assumptions.
马斯克在这段访谈中提到，制约火箭发展的重要原因是发射成本过高。为此，美国在上世纪90年代成功研发并发射了航天飞机。航天飞机最大的特点就是可重复使用，目的在于降低火箭发射的一次性而导致的成本过高问题。然而事与愿违 ，NASA 调查发现，航天飞机非但没有降低成本，反而在提高到了10亿美元每次，同时还造成了如此严重事故，这最终导致航天飞机项目在2011年被迫停止。如果用类比的方式来思考这个问题，就会变成：你看 NASA 那么强大的机构，通过重复回收航天飞机来降低成本，结果都失败了。如果我们也想通过重复回收火箭来降低成本，肯定结果也好不到哪里去。然后用第一性原理来分析这个问题则截然不同。同样的第一性原理用物理角度分析问题，火箭从物理上分析它就是一堆铝、钛、铁等金属组成的，每次发射必须消耗的物理成本是燃料成本。如果这个火箭可以重复回收无数次，那么你每次发射的成本将无限接近于燃料成本，这仅占火箭制造成本的 0.5%。 同时，制造火箭的这些铝、钛、铁等金属的价格其实也非常低，通常只占火箭成本的 7% 左右。关键是找到一种聪明的方法，把这些材料快速生产成火箭。这样的话，你既能够快速生产，又能够高效的回收，这个发射成本自然会降下来。现在 SpaceX 的旗舰火箭猎鹰9单次发射成本约3000万美元，并且重复使用越多，成本越低，制造成本仅3000万美元，且每年能生产至少40枚火箭。现在猎鹰系列是世界范围内成本最低、性价比最高的火箭，所以 NASA 才把日常火箭发射任务交给了马斯克。马斯克的这个访谈是2015年，那时候他的火箭回收还没有成功，然而现在他已经把当年吹的牛实现了。简单总结下，第一性原理的思想方式是用物理学的角度看待世界，对于任何复杂问题，你都可以把它无限拆解成小问题，然后用推理的方式一层一层的往前推理，找到最本质的问题。这个问题往往是非常简单的物理问题，着手解决这个本质问题，整个大问题就可以迎刃而解。相信很多人都遇到过这样一个问题：为什么我们上了10几年的英语课，还是不能和外国人交流？其实这个问题也可以用第一性原理分析，有兴趣的可以看我的这个视频。最后希望大家点赞支持，关于马斯克还有很多话题可以讨论。